that we can add to this. So just to give you a little bit background, I work on OpenEBS. It's a storage system that runs within Kubernetes. So one of the requirements that we had is how do we manage the disks that are attached to the Kubernetes nodes.
So anybody's taking minutes of the meeting, but you are taking, but you are just I can do it.
I'm sorry. We started prototyping this in OpenEBS repo, then we kind of spoke to Jan, Humble, who were working on the cluster FS, and there seems to be some similar requirements across different projects. We started discussing how do we put this into Kubernetes itself. So just walk through the presentations, the proposal slide that's linked on this issue. This issue is created on the H1 storage. So I'm calling this as a container attached storage, just like direct attached storage, network attached storage. So now with Kubernetes we have container attached storage, where storage is served from containers, right? So the common pattern that we are seeing is each of these nodes can be having disks that could be local disks. It could be I2C targets or FC targets, any kind of block devices. These are just referred to as disks, right? And these disk objects are kind of taken by a pod, or you can kind of call that as a storage pool. We talked about LVM earlier, so LVM is one kind of a pool. So the pools could be of anything, right? If it is a single disk, you could actually consider ext4 itself as a pool, and then you're actually provisioning multiple volumes on it. OpenEBS is one of them. LVM, OpenZFS, Portworx, FlashFS, Ceph, all of these can create a pool out of all these disks, and then you actually go and provision the volumes. Right? So one of the unique things about this container of the storage pod that we create here is it's part of a critical I/O path, right? And then these are long running. That you need to make sure they're resilient to disk errors. So you can't just have them go away, and then there can be some I/O latency issues for the applications using storage. Right? When we started looking at using the local PV, one of the drawback was you can't attach detached local PVs to these pods. You need to have the device /dev mounted, and that's the only way you can kind of do some kind of a disk replacement when you see some disk going bad or giving high latency issues. Right? It gets into that part. So these storage pods present a new requirement compared to let's say Ceph or sorry, not Ceph. If you're using local PV with MySQL, that requirement is different from a storage pod using these local disks. Right? We also want to get to a level on some environments where we want to know the hardware details, or the topology details of how the node is actually connected with the disk, especially if you want to use the NVMe-based SSDs kind of stuff. Right? And then how do we do some kind of a predictive monitoring of these disks even before the disk goes bad and the pod gets into an error state? Can you replace that disk with a new disk that is attached to the system? Right. Questions so far?
On this page, I'm sure there are two types. Is there different those or statically cache already is not them?
So these are already some ways in which we are deploying in the Kubernetes environments. We are trying to see that, okay, there is a pattern that we are all following.
I think what he's saying is that these these use cases require local disks, like the cluster. FS requires a device pool that which is clustered, can run like OpenEBS. So these are the use cases that we have that we need a pool of local devices actually.
So one other thing about this use cases is you, for example, like local PV is mainly for a pod running with a single PV, right? With the cluster FS or these kind of pools, you want to run multiple PVs on the same disk. Right? They are sharing that. Okay. So how do we even when we put this proposal out there, we kind of saw that okay, even local PVs can make use of this feature. It's basically writing that dynamic provisioners or the controllers on top of the disk. So once you have the disk objects available on the Kubernetes node, you can write these operators that can automatically provision instead of the static provisioner that we have that can actually make use of the disk objects that are available to do some cool stuff. Some of the operator challenges that we get, let's say we're using on-prem storage, right? How do we provide use cases like physically identify the disk where a particular application is running? Once we can write some high-level controllers that can actually make use of these attributes via the SS interfaces to identify the disk or give the topology at a much granular level. This is the kind of design that we are prototyping right now. So Notice Manager will run as a daemon set within the Kubernetes cluster, and it will make use of direct API to, let's say, LS block. It's just like there will be a similar implementation like LS block inside the Notice Manager to discover the physical disks that are attached to the node, and it will create a disk custom resource and push it to the Kubernetes CD. We can kind of have a lot of attributes of the disk spec is extensible in terms of what attributes you want to store there. Could be from the topology details to like the RPM or like whether it is provisioned on Amazon, Google, or if it is a local disk, whether it's SSDs, SAS, that kind of details. And the Notice Manager also has the capabilities of plugging in different probes. Using these probes, we can hook into attach, detach events of the disk, and then add new disks to the cluster, or you can kind of probe for errors. Typically, we do using the smart CTI cabinet, plugging into the Notice Manager so that you can subscribe for certain events. The storage pods can subscribe for the events and they can take corrective actions if those events happen. A similar error pattern is no problem detected. You can kind of consider this similar to that, right? It catches the demessage events and then publishes as a whole event that can be handled by the pods. Right. This is in a very early stage of implementation, though we have a prototype in a different repo. We are looking for help in terms of, is this something that you are interested in contributing to, or what are the requirements that you might have to design? I think that was the last slide I had. There are a few more, but I think it's a main.
I think there was a desire, like on the right hand side, from team that like we like to have a Rook.io has its own way of determining the device names that are available on which Rook itself should run. So there's a desire to have a uniform way of identifying available disks on a node, and that could be available for provisioning. So it could be local provisioning and usable by a higher level tool like ClusterFS or like RPD or Rook on which Rook is based on RPD. So his proposal is one way, like of I think we did not get into too much detail of it, but like it uses CRDs to discover the devices and create. Does it create PVs like directly or like it doesn't create PVs, right?
It doesn't create previous. It just creates the disk resources so that any other dynamic provisioners can use this information to create the data.
Okay, and the disk has to be pre-partitioned and everything. Unlike it has to be as available as just disks now.
Disks.
Yeah. Okay. So Rook IO uses config map based approach, where it's like when it starts, it scans the level disks on a node and it creates a config map with the device names that are available on the node. Then there's an operator that reads that information and uses that to provision basically like the RBD cluster. So cluster and like when we were deploying, when we were deploying local PV and we started testing internally, that was the problems that we have come across is how do we deploy local provisioning in production, and how do we make the devices that are available in the on the node available to the user, like to the user or for either for we don't support dynamic provisioning currently, so we have to use
to have an easier back.
That's correct. That's definitely one of the use case. So this can also be used by, let's say, some Cassandra operators or CD operators that are coming up. Them on nodes with disks with
of storage. We've standardized that for file and block. We've shied away from focusing on how you make storage available. We leave that up to third-party storage vendors. I think projects like what you're proposing that Kubernetes has established an API for projects outside of Kubernetes how to serve up storage. I wonder if this SIG home for this, just open that up to discussion, or whether it should be like, I mean, it's open source and collaborated on among storage vendors, but thoughts?
This is not very different from something like dynamic provisioning of local disks that we are trying to.
Right. This is the blurring of lines that's happening.
So like there as well, like we have chunks available, like let's say 1 terabyte disk available. Users are requesting devices. So the thing is, how do this plugins? Let's say somebody is writing a cluster FS plugin or how does it know that which devices it should use, for like something that is available on the node, and how do they become used inside the plugin itself, and maybe from there on, like how does it get exposed? So there is like two parts of the problem.
So I understand that, and my concern is that the primary benefactor there is just a few storage systems.
So to that point, I see a lot of value in what's proposed, and I think it's a great idea. My concern is, again, as Saad said, we've already kind of blurred the line with local block stuff, and my concern is if you introduce something like managing node resources to the SIG storage, I think we're going to get a little bit distracted. We're already easy to distract anyway. And the interesting point to me is there may be some globally interthing that's going on in this, but when you start talking about, I'm not sure why you would do a specific plugin inside of this project for cluster or anything like that, but that doesn't matter. But as soon as that comes up, then you're like, okay, now.
Right. Just I want to focus on small subs. Forget about like SES. We still have this problem on a large on-prem cluster of 2,000 nodes, and each node, like, we have introduced local storage in Kubernetes. We can't back away. We like on-prem cluster, we start testing this local disk. The problem becomes how do we convert these disks into PV that scales, not like. Okay, you have one node and you have 5 disks, you have it and you go ahead and create 5 big objects and then but how do we do this at scale actually, that scales to 2,000 nodes and like hundreds of disks. So let's forget about like OpenEBS or SDS part. The problem still remains that like even if you don't do dynamic provisioning, which I was talking about, but we have a problem of like how do we problem of like creating PVs at scale.
Is it unique to storage though?
Sorry?
Is it unique to storage?
It's,
Or are any resource on these valid that should be figured out how you advertise them up to make them available?
No, so you have still, it is like somebody or something has to go into all the nodes and create like PV objects, right? Just theoretically speaking.
I mean, but the question is like what types of objects? So like you've got GPUs,
Yes.
right? You've got disks, you've got maybe special networking stuff. I don't know. I think you could abstract it and say there's lots of different resources that all of these folks have, and they can actually start consuming them directly. So I don't think it's a challenge unique to storage, because all you're doing is taking a device and making it an object in Kubernetes, and you can say that's the same challenge for many different things. So I think I agree with Saad. Like, is storage the right place to solve that? Or maybe the node is the right place to solve that general challenge of advertising node resources up.
Or even the app state, because when you get down to it, a thing like Cassandra, a stateful app, and most people call these apps just because you export an API that's commonly used for implementing storage. Doesn't mean that outside the general category of running an app on Kubernetes. If we open this up to all forms of apps that use storage, where are you going to draw that line? Really, maybe this is outside the scope of this.
So I think device plugins is one good way to think about it. So does the implementation go towards the device plugin? So then should it be, we still need like something like a resource that represents a disk, just like CPU or GPU, right? Should it be a SIG node?
Well,
Networking.
one challenge is that storage compared to other resources, storage has like for GPUs and stuff, GPUs, left and right is an heavy resource and it has an identity that needs to be persistent for them, and that identity needs to somehow identify it and be able to store it somewhere and make sure we don't deal with the disk with just anyone. So I think storage might have some unique challenges there.
Storage is stateful, so it's like there's already a device plugin here. So there's an NVIDIA / GPU, and that could be specified already. There's a GLP that picks and it gets added to container specs and picks. it's up all the way to the node capacity, and then it works as it's expected to work. But for storage, we have different problems. Like to solve that problem, if you want to solve it in this SIG or not, but
Well, if Cassandra came to this group saying they wanted in, they thought that this SIG was the proper place to discuss Cassandra, I think we'd say no. Yeah, what's different about what you're proposing here from a multi-node generic
I
stateful?
think to restate Amon's statement, it's not necessarily about the application level. It's more about the feature that we've already invested in, which is local storage, and making that more robust and capable. We've already agreed that local storage is something that the SIG owns, so I can buy the argument that this is basically improving that feature.
we agree that bandwidth provisioning of local storage is a hard problem. We agree that, and we also have seen when we try to deploy, I don't know how many initial and used local storage at scale, and try to create, particularly when you have permissions, users who cannot see that use the local storage, it becomes tricky. So we want to solve this problem for all the use cases and the creation of individual objects. So that's one of the primary goals actually. The benefits that yes, within EBS, cluster or other volume tag process devices. That's my secondary to the primary.
I guess let's raise it one more time though, because frankly, Cassandra consumes. So what's different here?
I mean, the difference is that we don't care about the workload necessarily, whether it's Cassandra or EBS or something else. We do care about the local storage persistent volume feature that we've exposed.
Okay.
In order to complete that feature, and I don't fully understand this part, but it sounds like what you guys are proposing is going to make it easier to
So, we want to make it easier. So let's open up for discussion. See, if you really want to solve. If it makes sense, then you can do it.
yeah, and I mean, beyond that, like if there's folks in this community who are interested on it, that's worth. Cool.
Do you think there's anything that needs to change inside of Kubernetes, or can it just be built as a controller?
So right now, the way we are going ahead, nothing is changing within the Kubernetes, trying to use all the API that are already available.
I think like Mohammed feels very strong, like he approach that obviously doesn't need any CRDs to be defined. You can just put the device name in the config maps, and then like from there you can provision code. So that's another way.
It's a implementation choice.
Yeah, that's an implementation choice. So I mean, it doesn't have to be core Kubernetes to be saying the solver approach, but we need to come to a consensus of solving this problem. No, they already have it. It works, and it just that like for our use case, like in particular for CNS, the cluster piece, and then for PS, we are trying to see if we can find a uniform way of identifying all this and like how to expose them. Like yeah, how this available how to expose them. We have
So what I'd like to understand is why is this necessary? Why would having a Kubernetes representation of the disk object help local storage?
It is that the help provision the previous or the previous side. At the top that Michelle and Kiran gave. There are a lot of pre and post steps that we have to do. Kind of ties into that.
So managing the data, what you've done to which disk, yes.
There's another level that like such as the health of the disks.
Yeah.
So you've got 50 disks in a host, so you probably want the health of those to show up in the objects. So when you choose disks, that you're using healthy disks, that can provide value to it. So it's not just advertising 50 and being done, managing the lifecycle. 50 still be advertised for whatever reason.
Monitor the health of the
Differentiate both the tracks of storage. You could have NVMe as systems and database. So you could expose that and put in a more intelligent selection of tests for creating process points for performance.
Yeah, I think that it's really all about feeding the local piece, right? In terms of what gets last thing and the discussion that got to the application level of, you know, Cassandra or Bluster was a distraction here, and that it's really about feeding the local PV pool, if you will, that all those applications can then use.
So I just want to capture all these comments and then see how we take it.
Yeah, I think I did a very poor job.
So if anybody wants to volunteer to help on the design of this,
So what are the next steps here? What are you looking for?
so we are in the initial stages of preparing the design. Any inputs to the design is good.
I think currently we're missing two people who are like who are knowledgeable about this. Yeah, so yeah, particularly what we can do is we should probably have another follow-up call like it's big enough topic that it will be each up 6 so it's like the meeting time and every require so separate call and if we can have VP or private call and then follow up with that. Right?
Yeah. CSI.
Yeah.
We realized there were so many things going on. We started using the weekly, bi-weekly call. We would all the time set up separate meetings for CSI.
And do that and send out the inviting message to range.
Yeah. Cool. Thank you very much.